Welcome to Black Hat Briefings, held November 21st through the 22nd, 2001 in Amsterdam. This is videotape number 11, Web Application Security, the land that information security forgot.
Jeremiah Grossman, the land that information security forgot. I'll be talking about web application security and what it means to all of information security together with all the other security-related implementations that are out there. But first I have to apologize for my shoddy PowerPoint skills. I got called in at last notice, and what you have in the books is not necessarily what I have up here. It's close, but there's more information up here, and I hope to go over it in a more detailed fashion. At any time, if I go a little too fast or it's a little too technical or you have a question or anything like that, just fire away and ask. Most of my experience is gained through years ago being a web application developer, dealing with millions of users and just seeing a whole lot of web applications in the field and trying to come up with secure solutions, new attacks to complex web applications. Because as we all seen, web applications are just designed to do all sorts of incredible, amazing, and stupid things. So that's what we'll be covering. The attacks here, some are simple, some are classic, some are advanced, some are very new, just all different kinds. And but web application security is kind of like the forgotten child in all of security, and it tends to be one of the more easiest avenues to exploit a user, a network, host, and the like. So we'll begin. So I'll just briefly describe what I'll be, again, what I'll be covering. The landscape of web application security, how it fits into the model of how it's implemented in a real-world environment. Common web application security mistakes, the things that, if your focus is to check for vulnerabilities in a web application, what's the first things you look for, what every web application tends to be vulnerable to. We'll go over a lot of those. And some of the new stuff, some of the lesser documented attacks, the attack methodologies behind some of the more clever attacks that we'll tend to see in the field. Namely, I'll try to take the approach of, if you're developing a web application or you're tasked or chartered with auditing a web application, what exactly is the approach to scanning or auditing or discovery process of that web application? Because many times, you'll be working on an off-the-shelf web application or web platform, and you might have access to the back end, but a lot of times you don't have access to anything, and you have to take a strictly black box approach to figuring out what the thing is, what the thing does, and what it's vulnerable to. So the first thing we'll go over is information and discovery, basically just figuring out what everything is, what everything's running on, versions, etc., process flows, and even more. Then we'll go into some of the exploitation with input manipulation and parameter tampering, the very badly named cross-site scripting problems and how dangerous they can be, and also system misconfiguration. But why is web application security so dangerous? Why is it so easy? Why is it important to as administrators and as security people? It's generally to be, argumentatively speaking, the easiest way to compromise hosts, networks, and users. We'll cover that why, but it's really easy to do. It's really easy to target users, people, or systems using a variety of methods and attacks. Web development platforms, web implementations all over HTTP or HTTPS are widely deployed. They run on just everything now, and they do everything, and more so in the future. Better is that there's no logs. Most of the time there'll be a little bit of logging, but there's no logs of, especially in post requests, what the payload of the attack actually was, what you actually did, or how the attack took place, or anything of the like. It's just a ghost attack. No one ever sees it. No one ever thought to see it. They're incredibly hard to defend against or detect. Normally these web attacks, they're so diverse and so system dependent that a developer, most times, even if they want to really secure their web applications, they're incredibly hard to even figure out what the attack is or how to defend against them. And then there's the other side of the token that most web application developers really don't think of locking down their web applications ever. It's just an afterthought. And it's very important when designing a web application that you take security seriously from the get-go and design it with that approach. If you don't, it's nearly impossible to secure it after the fact because the whole design is all wrong. Intrusion detection is a joke. Intrusion detection, generally speaking, it looks for known signatures. It's at the network layer and has absolutely zero bearing on a web application attack. And even if it did, web application attack can be easily modified to beat just about any filter out there. I've never come across an intrusion detection tool that actually stopped any of these attacks. And, well, you know, some may say, well, there's a firewall in place. Well, most of these attacks, port 80 is open, port 443 is open, HTTPS, HTTP, you know, whatever the port that HTTP runs on, firewalls mean nothing. They're letting traffic in. The whole world knows about the service. Firewalls completely disappear from the whole architecture. Encrypted transport layer does nothing. It's just encrypting whatever you send across. It doesn't tell you what you can and can't do. It's just encrypting the traffic as it goes along. And best of all, no one is looking anyway. How much easier can it get? All these things put together makes for a very secure and very dangerous environment, but there's always Unicode, and if you're still vulnerable to Unicode, may God have mercy on your soul. So let's get the basic understanding of what I think a web application is. A web application or web service is a software application that is accessible using a web browser or HTTPS user agent. At its simplest definition, that's what a web service is, or a web application. You send a request, you get a response over HTTP or HTTPS. It's just that simple. So here's a top-down approach on how the architecture is designed, you know, from when we see most implementations. At the top, we have the user, followed by the transport layer. So we're separating layers from dangers. So at the very top, the user is actually vulnerable. This is a limited list, but they're vulnerable to cross-site scripting, spoofing, trickery, and many, many more. The transport layer is vulnerable to passive monitoring, so that's why we use SSL, but there's man-in-the-middle attacks and session hijacking. The firewall allows HTTP and HTTPS, so that kind of just goes away. The web server itself, which is separated but sometimes closely related to the web applications, are vulnerable to buffer overflows, format string vulnerabilities, directory traversals, default accounts, SAPL applications, everything you know, everybody in the room knows about anyway. Web applications are vulnerable to many, many things, namely filter bypass manipulation, which is kind of very new techniques on how to defeat commonly implemented security safeguards. There's meta-character attacks, null characters, buffer overflows. And there's the internal firewall, which might be part of the external firewall, but VLANed off. But basically, the middle section here is actually the DMZ. And then we have the internal network. If you're able to successfully launch an attack against the web application, actually land on the web server, normally there's an open communication path to the open database. So you can actually use the web application to leapfrog further in. And this happens more often than not. So implementations. What are people out there using these web applications for? Well, in the e-commerce world, there's shopping. I mean, we all use these things already. There's shopping, auctions, banking, stock trading, and a million others that do all sorts of stuff. In for entertainment value or just plain take up your time value, there's message boards, webmail, guest books, voting polls. There's search engines. They're all web applications, and they all perform a variety of functions and do all sorts of nice stuff. And then there's the just plain crazy category. Basically, I've seen web applications now show up on printers, PDAs, cell phones, to configure your systems, and there's also the .NET and Passport. Basically, everything soon is going to turn into a web application, and the underlying architectures, the systems are just beginning to disappear. Who cares what's underneath when you have access to the web application? Doesn't matter if it's the firewall, doesn't matter if it's encrypted. Sooner or later it gets decrypted and the web application has access to it. Imagine like if a printer is web enabled, you can attack the printer on the network, which is a printer now with a web application, just a mini computer, has like a 10 gig hard drive in it, has all types of system commands, and you can leapfrog off the web application into the internal network using the printer. As we saw in an earlier talk with cell phones and PDAs, that they're WAP enabled, which means WML script, which gives you all types of access to phone features or just functionality in general that you can play with. System configurations, I don't know how many in the audience are familiar with Compact Asset Insight Management, but that's a whole nother platform that's just a whole web application with a whole mess of tools that, you know, just begging to be played with. Just things like that. And then, of course, there's, you know, again, the .NET Passport that just has so many features and functionality, nobody knows what the hell's going on. So, through the firewall without a fire suit. Most firewalls, you know, on good implementations of firewalls, block just about everything except web, given that it's a web application, e-commerce environment, or something similar. So RPC block, NetBIOS, FTP, and back orifice. But you still have direct access to the web server and all the underlying web applications. And the firewall does not help you because it allows web traffic because it seems harmless. As long as it's going over port 80, the firewall really doesn't care what it is. Now, this is a very common one. SSL makes me secure. SSL just guards the transport layer, so nobody can snoop on it, or that's the theory anyway. Now, you know, SSL is great. It, you know, just simply encrypts my attack on the fly. So, let's see. So we're going to go over some common web application security mistakes. These are the mistakes that we'll find in just about every web application. Most of this information is not complete because web applications, the platforms, the technologies they run on are not well documented, and the attacks and the combinations of those attacks are not, could not possibly be defined in any easy sense. So we're just covering some of the basic ones and maybe a few more that aren't on the list here. Is there any questions so far? Okay, good. Pretty easy so far then. Okay, trusting client-side data. This is the absolute worst thing you can do if you're developing a web application, and absolutely the first thing you should look for when auditing a web application is the client, your browser, your telnet session, whatever that you're sending into the web application. If the web application trusts whatever you're sending it, whether it's cookie data, parameters, headers, whatever, if it trusts it, it's vulnerable. That's just as plain as that. It's the #1 cause of vulnerabilities. You've got to imagine like these multi-million line codes of web applications. Sooner or later, they're going to trust something coming in from the client, and that's what you got to find, is where it's trusting it, at what point. Further speaking, in sequence of events in web applications where you have page sequencing, one event is dependent upon another event, dependent upon another event. For instance, like shopping, you hit buy, the price is okay, you go to the next phase, you put in your credit card data, then you check out. Well, somewhere in those middle processes, the price or whatever the item is going to be kept live, and you can change it at that point because it's already checked it once. It has to check it again, and 9 times out of 10, it just doesn't. So here's an example of that. In a lot of e-commerce shopping environments, you know, not all, a lot of them are taking care of this, but it's not limited to just pricing. It's expanded to everything. So let's say we have, you know, we're buying our new Sony Vaio, and we hit buy, and we view the source in that page. In that source, we might see input type equals hidden, value equals $2,149.37. You know, an average price for a nice Vaio. Well, that's too much for a Vaio, I don't have the money. So I just quickly alter the stream, alter the HTML, resubmit for $2.99, and now it's on extreme sale price. So here's some examples of parameter tampering straight into the URL. It's just the level of trust that web applications put in search strings queries or template files or whatever. In this example here, we have two parameters. We have value, or val, which is equal to string, and file. Conceptually speaking, the CGI application is searching the named DB database for string. But if the CGI is stupid or isn't checking properly, you could easily put in root or file, and you change and you hop up to the password file. You might be able to get the password file. This works everywhere. Another iteration of this might be to, if they have a credit card database that's accessible, just put in string of like 0 as the string, and you can dump the whole the whole credit card database file to you. It's very nice of the web application just to give up all his credit card numbers to you. The next thing you should look for is unescaped special characters. Special characters or meta characters, whatever you call them, they have all different types of meanings on all different types of systems, from Unixes to Windows to Mac OS. Every system has special characters that could be expanded into a number of things. When checking a site out, you'll be able to wander around, look at input variables, or plug in your own input variables, and see what happens on the response. You inject these special characters just to get some kind of error, some type of response, something misconfigured. And if it does, chances are it's expanding these special characters or using them in some dangerous way. And all you have to do is figure out how to take advantage of it. So these special characters are very dangerous. And speaking from a deployment or design point of view, if you're taking in web content or parameters from the user or any type of input from the user, if you're expecting special characters, you must escape them. If you don't need them, delete them. HTML character filtering. This relates to cross-site scripting, and I'll get to more in depth on that as we go on. A lot of times you can put in HTML tags and just watch the echo response, and if the tags aren't properly substituted like they are on the right there with HTML entities, chances are you can get a cross-site scripting exploit to execute, whether or not it's auto-executable or click-executable, and I'll explain the two concepts later. But basically, if you can get these to go clean through and get them to echo back out at you, there's something wrong. Oh, yeah, null characters. Null characters, %00, a lot of times will be interpreted or not removed, and remove the rest of the string that's beyond it. So you might be able to alter a string on the fly using the null characters. So from a design point of view, if you should always just emphatically strip all null characters as they come in. More mistakes. If you're able to execute some system level command, or you're reviewing the source code of a web application, check for the SUID bit. Web applications, many times when they're performing some administrative tasks, will set the will be SUID to root. And if you're able to execute a system level command on a SUID root, you have all the power in the world. You don't need any more privilege escalations. The web application already did it for you. All you got to do is just figure out what you want to do. Authentication mechanisms using technologies such as JavaScript or ActiveX. This relates back to trusting client-side data. If you're planning on trusting client-side data, be prepared for compromise. These two technologies are all client-side. It can always be manipulated on the client side. So once you see a site doing any type of sanity checking client-side, authentication client-side being any technology, not just limited to those, there's a problem with the whole system. Lack of re-authenticating the user before issuing new passwords or performing critical tasks. This will relate to a lot of cross-site scripting or session replay attacks where you can take control of the administrator. Many systems will allow you to change passwords or drop database tables or delete users without the need for re-authentication of the administrator account or whatever the admin account happens to be. As an enhanced security measure, if the task is particularly critical, check if that function is being required to enter a new password. If it's not, then that's a definite hole, because you can definitely take advantage of that user and perform a critical task, possibly without that account user even noticing. And another big mistake is hosting of uncontrolled data on a protected domain. For instance, let's say you're visiting eBay. When you visit eBay to peruse around, you're generally trusting eBay not to post any malicious data that might screw with your browser, screw with you, send you off to a bunch of porn sites which you can't get out of. You're trusting them to do that. Many sites will allow users to host like profile pages and the like, and allow other people to host uncontrolled data on a protected domain. This has serious implications, because now that uncontrolled data has the same access to the user's environment as the site itself. It can do whatever it wants. They actually host on your domain. So we'll enter the first stage of how I perceive to go about discovering or pounding on the black box of a web application. First thing I'll do on any web application, doesn't matter how big or small, is I'll spider the thing. And this gives up a lot of data. The first thing I'll do is spider it. Then I'll look for identifiable characteristics. I'll go over, does somebody have a question? Okay. Identifiable characteristics, followed by errors and response codes, file application enumeration, and network reconnaissance. So to go over and further define spidering and site crawling and what it gets you, it's important to understand what the web application is doing. To be able to manipulate the processes, to manipulate the underlying platform, you have to know everything about everything that it's doing. And a good sitemap, a good crawl will help a lot in doing that. You'll also get a service map, which is different from a sitemap. A sitemap gives you a good layout of the pages and how they interact and how it's directoried out. A service map actually should tell you what services are running, what they're doing, and how they interact with each other, which is another abstraction removed from the platform itself. Then look for any documentation on any of the services that you find, how to use them, what they do, what they tell the user to do, help files, whatever. Wealth of information in that regard. Get all the documentation that you can. Hidden services. Many sites will just plainly not have will have like administrative functions that are not easily accessible. I say easily because they're just hidden. It's just a hidden directory off the web application, so you can just start appending like /admin to the domain, /administrator, stuff like that. Look for hidden services. A lot of times you'll find pointers to that information in comment lines. When spidering a site, you should also log every CGI in every form and every variable to every form, because those are all interfaces to the same systems, the same web application. And log all email addresses. You never know what email addresses are good for not only contacting the administrators to gain further information, but they're also good for grabbing user accounts. You're not interested in the domain, you're after user accounts and just all the data that you can. Good software to use for doing all this is wget. A lot of times I write my own spiders to get more things, but wget is a good place to start. Identifiable characteristics. Most times in HTML pages or just any interactive web application, the developers will put comment lines, whether they be server-side includes, notes to themselves, remove this later, or this function was set to do this at, in the future, blah, blah, blah. And they hide all kinds of stuff in the comment line. So it's incredibly time-consuming, but you're going to want to view source and look at the comments in every single page. Whether you can spider for it and automatically pull out that information is completely up to you. But it's also a wealth of information. URL extensions. It's a great, easy way to figure out what the system is. If it's a .asp, chances are it's running Windows with active server pages. JSP, it's running Java server pages. Just gives you a quick indication without port scanning, without doing anything of the kind, what type of system it is. It'll just give it up and tell you. Meta tags. These just stored values and stuff like that that administrators tend to put in. A lot of times they get information, sometimes don't, but it's a good place to look. Cookies. Cookies a lot of times will have great information, especially on what type of system it is. If you see an app session ID, it's going to be Windows. Every different good web application system has a different way of implementing cookies, so you can actually get a really good idea of what the system is or the underlying platform is just by looking at a cookie that it sets. Also get a good idea of what client-side scripting languages it's using. Is it using JavaScript, JavaScript, VBScript, Java, all the other ones. It always serves to help out as much information as you can. With all these combined, there's just a wealth of information without actually exploiting anything about process flows, debug commands, system types, configurations that go a long way to exploiting a web application. You're basically just casing the joint. You're trying to figure out what this thing does, what it's made out of, and so you can better align your attacks later. Then there's error and response codes. I don't know how many people can do HTTP by hand by telnetting to port 80, but a lot of times the server will give up what type of server it is. You'll be able to look at cookie characteristics and all sorts of stuff. Every request you send out, Netscape or IE will send out a whole bunch of HTTP headers. The server will send them back, and it's just good to look at all that stuff. Error messages, a lot of times you can force the web application to error by putting in a whole lot of values, a whole lot of, if it's asking for a number, put in a negative number that's really extremely huge and get it to fault. A lot of Java and SQL are notorious for this, spewing exploit or exception code to you once you put in something that it can't understand. 404 error pages also give a lot of information about what's there and what's not there. Let's see, failed logins. Those will give you information about what accounts are there depending on the type of error messages that it is. And which rolls into locked accounts. And you can also check if database files are there or not there. Error messages can be really valuable in brute force attacks or just any kind of system information gathering. File application enumeration. There's basically two methodologies in this. There's forced browsing, which sort of relates to CGI scanning. You can use Whisker to perform a CGI or vulnerability scan, or one that you wrote, or another one you can get offline. And but a lot of times that particular tool or tools of the like won't tell you or help you out at all with a proprietary application because it's just not going to have standard vulnerable CGIs. Directory index browsing, many servers will give up the index. If you just start peeling off directories. For instance, we could start with that top example there, the file.html. You just start stripping off directories, and it'll give you an index of everything that's in there. You can get config files, temp files, sample files, anything that they didn't link to or haven't linked to yet or use in the future will help you to exploit the system and find vulnerabilities. So file application, as I said, will give you access to sample files, template directories, temp or backup files, hidden files, or vulnerable CGIs. Temp or backup files is an important one. Sometimes, like when using VI or a number of text editors or whatever, you'll have a temp file or a swap file or whatever that's also created with the executable. So you'll be able to get the source of a web application just by searching for, the temp files depending on the platform. That's why you did all your previous discovery. And there's also network reconnaissance. It's not necessarily related to web applications, but it's always really good to have all these tools at your disposal so you can see the whole network as it lays so you don't miss any web applications that are currently in function. You can use whois, a RIN, you can port scan the boxes, trace route to them, ping scan them, DNS lookups to see if they're load balanced or see how many are behind them, zone transfer to figure out more hosts, and there's also OS fingerprinting. Like I said, not directly related to web application security, but definitely should not be forgotten about. So, any questions so far? Anything I'm going over too fast or anything like that? Input manipulation and parameter tampering. Twiddling the bits. We'll go over these attacks here. Cross-site scripting, filter bypass manipulation, OS commands, meta characters, path directory transversal, hidden form field manipulation. We'll go over each of these, what they mean, and how to defend against them, how to exploit them, and the like. So cross-site scripting. The term is very bad. It's a very bad name given to a very dangerous security issue. The attack targets the user of the system rather than the system itself. A lot of times, while doing these attacks, the system might actually be secure, imagine that. And rather than attack the system, I figured, well, why don't I just attack the administrator themselves? I mean, they're allowing me to write to their site. I can pass information through them. It basically gives the outsider, the outside client languages, executing within the user's web environment the same privileges as the hosted site. Meaning that if I'm able to sit in a chat room, sit on a message board and post, I can post things that actually will execute within the environment of another user. And for that instance in time on that hosted site. So I'm visiting site XYZ and posting information. When another user lands on that domain, I am XYZ for that moment in time. I am that site to do whatever it is I want to do as that site could. So how does client-side scripting languages work in this whole scheme of things? Well, the basic starting point is all about HTML or DHTML, all the other derivatives. It opens up all the other doors to everything client-side. So we have JavaScript at the top there that can do all types of browser and DOM manipulations. Java, which could do just about everything else, and even to asking the user permission to do even more nasty stuff to the user's machine, and chances are they'll click yes. VB is very similar to JavaScript. We have Flash that provides enhanced interactivity to the DOM, and it also has lots of client-side scripting languages and lots of APIs relating to JavaScript within Flash. ActiveX, I couldn't even begin to tell all the different ways this thing is incredibly dangerous. ActiveX can completely exploit your home machine. It has access to everything on any Windows box. I couldn't even imagine what this thing does behind the scenes. Then there's XML and XSL, not too implemented yet on the client side of things, but XML and XSL are definite door openers once again. So as browsers or any HTTP client starts to implement XML, there's going to be a whole new range of problems. We've been doing a lot of research on XML, XSL, and .NET, and we've been finding vulnerabilities in these implementations that aren't supported yet. So when browsers start implementing them, we have vulnerabilities that are purely theoretical. And there's also CSS, which has a lot to do with JavaScript. You can manipulate CSS in weird ways to manipulate the DOM, so it's also pretty dangerous. So when I say DOM, it's actually Document Object Model. The W3C, is it? Put it all types of proposed methods to manipulate the DOM to give these client-side languages access to the document object model to manipulate them. Everything ranging from colors, links, location, browser type, system type, to change and modify just about everything in the whole system. And it's been up to the browsers thus far to try to secure the interaction with that document object model. But sadly, they've done a pretty poor job in doing so. So kind of at the mercy of these client-side scripting languages. And how it gets worse is a lot of these technologies will interconnect with each other. Java can talk to JavaScript, they can talk to VB script, they can talk to Flash, and interconnecting, and they all have different levels of privileges. So you get them to talk in the right way, you can get total system access right through the browser. So going a little bit further, let's say we can get JavaScript onto the system. Big deal. What can we get? And how do we pass that data out? Because it seems like it's very stateless, so how do we pass it out? Well, it ends up being particularly easy. So cookies have inherent security within them where one domain's cookies should not be sent or accessible by another domain. So how do you cross domains? How do you get across the barrier that it implements? Well, you just basically do it totally in memory. You just bypass all the security. What happens is, in JavaScript, there's the expression document.cookie, which holds the string of the entire cookie value from the domain in which it was loaded. So you have this incredibly huge string. And all you have to do is set up another GET request via a few methods to pass the information off. Now, this is not restricted to cookies. This is anything that you could set a variable to in any scripting language. You can move in a whole huge amounts of information off the user's machine about system types, internal files, anything you want, anything you can able to get access to through a browser bug, you can pass it directly off transparently right through a GET request. You open a new window, change the source of an image, you hit inform submit, that auto executes, and you just pass the data, I have it here, cookie data, to a CGI that you control. It just passes off. I made a cookie stealer once on a web application that I created that every time somebody looked at the page, I would get the cookie of that user illegally, my web application, of course, and it would ring my pager. I'd get cookie data on my pager. It was just that simple. Once you have the cookie data, which a lot of times has authentication credentials, you can reuse that data. You know, you replace it in your browser, replace it into your own HTTP client, and you also need to become that user. You just stole the whole session, and they were none the wiser. The whole security system was circumvented. So, scenarios further with cross-site scripting. Well, if you can redirect the user via like document.location, you can trick a user to relog into a spoofed page, and 9 times out of 10, the user won't know the difference. They'll just type in the user information, log in, and all of a sudden you get their login credentials, and you can just forward them onto the real login page, and you have access to the account. Before I go further, a lot of what I'm talking about is getting to the point where you can where you can successfully attack the user and beyond. So I'm focusing more on the implementation, how to attack the user, how to bypass the security, to do, you know, all these things here. You can compromise authentication credentials. We just went over that. We can load dangerous and malicious ActiveX into the user's environment. I noticed an article where a lot of pornography sites are doing this. We're loading dangerous ActiveX and changing the default home page of all the IE users' pages. So that was just one of them. You can redirect a user or all users. So for instance, if you're on a large message board, maybe like EasyBoards or something huge like that, or I don't know, posting some feedback on some book page or anything like that, if you're able to get JavaScript in there, you can actually redirect the whole site or a particular user to a whole other place, and they'd never be able to get back there. Or you could redirect them to a site that looks like the same site, and you know, they just go along. So you can redirect the whole site. You could actually do, who needs DNS poisoning when you have JavaScript? So, and you can also crash the machine or the browser. Somebody have a question up front? You can also crash the machine in the browser. Browsers are, you know, very fragile. You can just shove all kinds of nastiness into the browser, and chances are the CPU will, you know, peg at 99% and then die. This is one we've been able to achieve in the past. Sorry, I don't have the code here with you to give you an example, but the concept is sound. CSS, danger, the remote launchpad. Imagine, well, let me just go through the logic. It's just a 3-step process. You successfully CSS a user, cross-site script a user on a protected domain, or whatever the page is, or whatever the mechanism. You utilize a client-side utility, like JavaScript or ActiveX, to exploit a browser hole, a Trojan, or a virus. If you don't know one, just wait a week and there'll be another. User is a knowingly infected or compromised within a single HTTP page load, ActiveX, and I've also been made aware of there's an ActiveX netcat. So basically the way it works is, let's say you're using a webmail, somebody emails you. You don't even have to read the meshes most times, and all of a sudden, 1, 2, 3 can happen to you in a blink. You read the web page in your browser, and bang, you're netcatted. It's just that simple. You bypass any of the zone security stuff. All of a sudden, there's a backdoor in your machine, through the firewall, through your antivirus, through whatever. You're just screwed. So we'll go into now how to get these CSS attacks to launch. If you're from the design point of view, if you're responsible for designing web applications and you need to implement HTML into your system, you need to allow your users to implement HTML, well, these tags here, don't allow them, ever. These tags are the worst of the worst. I should just say at this point that if at all possible, when designing a web application, do not ever, 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 unless you can help it, allow users to implement HTML into the environment. Avoid it at all costs. And I don't know if I'll go over each one because we'll kind of see some of them. To the right there is why these are dangerous. This is not a set list. There's always new HTML coming out with every version, but these are the main ones. These are the ones I know about that you should never, never, ever allow. And the attributes that go along with them. We saw in the past slide that those tags are dangerous. Well, any tag with these attributes are dangerous, which is pretty much most of them. Don't ever allow these attributes. If you need to allow the tag, make sure you strip and filter for these attributes because you don't want users using them for very bad things. So filter bypassing. JavaScript is a cockroach. Every time you try to get rid of JavaScript, a lot of times it just shows up again. So if you're allowing HTML, you're going to have to deal with this problem, so I figure put it in. There's all types of ways. This kind of started like years ago as a game. You throw HTML into a system, and you mess around with the users, and they get all pissed off. And then the administrators would try to filter out what you're sending in, and you beat the filters, and then they filter that, and then you beat the filters again, and you filter that. So these are just filter bypassing approaches that we've picked up over the years. So we'll go over known ways to circumvent commonly implemented filters, and we'll also the attacks will mainly depend upon the system allowing HTML into the environment. So that's at least our assumption. So let's say you're testing a webmail system, a message board system that allows HTML, or any input variable that's supposed to allow HTML. Well, we'll go over kind of the easy scheme of how to test these web applications. The first thing you do, the absolute first thing you do, is you just start shoving HTML every single tag, go right to the RFC, go right to the WC3, and shove every tag you can into that system and figure out what comes out on the other end. And then you can get a good determination of what it's filtering and what it's not filtering. This gives you a very easy way to find a single exploit in about 5 seconds. That list I gave earlier, you shove all those in there and see which one doesn't get filtered, and bang, that's an exploit. So, also, all the tags you shove in should also have those key attributes that I said that you probably shouldn't have. Source, style, href, and on, which is the JavaScript event handler. You also might want to stack these up on each other. A lot of regular expressions, filtrations, will filter the first instance of source and just remove it. We'll just put 3 or 4 in there, and one of them will get through. So the first one, let's start very basic on how to get a cross-site script to work or to implement it. So these are one of the tags you shouldn't have. But if it gets through, the first one is, I'll give some real examples of these, but for now we'll just go over the theory. The script tag will just easily allow you to implement an alert JavaScript executed. How I do proof of concept without actually exploiting the system, I've already done all the aftermath tricks so many times that if I can simply get an alert window through, I know I can do everything else. So these are just my simple proof of concepts. So the expression alert is executed with a simple script tag when it makes it through. Sourcing the JavaScript protocol. There's where it just starts getting crazier and crazier. The expression JavaScript colon, I guess it actually just sends a GET request through the location bar in Netscape and in IE, and will execute the expression after the JavaScript colon. The good countermeasure to it is somehow just altering the JavaScript colon method, or a protocol, and just changing it, thus rendering it inoperable. But I also found in Netscape that LiveScript and Mocha do the same job as JavaScript. So those are the 3 keywords you have to filter for in every instance of the source attribute, and not just limited to the image tag. Sourcing JavaScript protocol with HTML entities. Gets even crazier. In the JavaScript protocol there, you'll see the HTML entity in there. I believe that's tab or some type of white space character, the ampersand pound 09 semicolon. 10, 11, 12, and 13 will also work. This has all been tested in Netscape and I believe IE as well. And these will still execute. So if the system is actually trying to filter for the streams Mocha, LiveScript, or JavaScript, and it just has an easy pattern match, well, just throw that in there, and it beats the pattern match filter, and it goes right through. There's the and curly. I can never figure out why this one worked in Netscape, but we found this a while back. Ampersand, curly brace, expression, then ampersand, and then curly brace, semicolon, and that executes the expression. So if you want to build your pattern match filters, filter for ampersand curly brace. And the syntax to test this has to be absolutely perfect, otherwise it won't work. Style tag conversion. Many think, and I think cascading style sheets were designed to alter the document object model, change the look of the page. But for some reason, there's functionality in both IE and Netscape that you can actually import other dangerous JavaScript and CSS into the environment. You can just source it in. So the first one there, you can change the type to text/JavaScript and execute a JavaScript expression. Why that's in there to do that, I have no idea, but it is. Style, you can import new cross-site scripting languages, and you can also import a URL that way in the third one. It's an IE hole. So you have to filter at import and, of course, the JavaScript protocol. Actually, let me go over. Let me drop out of here. So can we see this? Yep. I don't know. Can you see the line of JavaScript in there? Okay. That's just, I'll try to separate it out. Hold on a second. Better? Okay, so this is just a simple example of a script tag. So, we'll just slowly play along with it. So we can see there that JavaScript launched. So we can start playing with this now. Just start putting carriage returns in there. Save it. I guess that didn't work. So we have the script tag. So we'll start simple, and we'll move over to image. We'll just give a few examples. So we have the image one with the JavaScript colon. Launched. So we can put a single line break in there. So for instance, if the pattern match is looking for JavaScript colon or whatever the keyword happens to be, it's looking for JavaScript colon, and if you put a line break in there, see what happens. Still loaded. We can put a few more. Still loaded. So this is why JavaScript gets really, and HTML gets really crazy. There's no adhere to format. It just keeps loading under all types of circumstances. So the regular expressions get really crazy to deal with. What's that? Oh, sure. Like that? Loaded. It'll load under so many different environments. All the examples, you just change it and change it and change it and change it until you're beating every single regular expression that's implemented. go back here. Are there any questions so far? Anything? Sure? Okay. So going further, how do we implement cross-site scripting and get it to work in a real-world environment? Well, a lot of times we see out there, especially like on bug track and such, we have the click-to-execute ones, where I'm going to try to break down cross-site scripting in the different ways it gets dangerous. The first one is click-to-execute, where the user physically has to click on the link to execute the GET request to get cross-site scripted. These are dangerous, but they're not as dangerous as some of them. You'll find them in search fields, where you'll notice like on Google or something like that, where you can you type in an invalid search and it'll echo back what you implement, what you submit, what you search for that it didn't find. Well, you just start putting crazy HTML in there or finish up their tags and start your own and such like that, and you can get all these types of things to work. 404 errors are notorious for this, when they echo back the page you didn't find and it echoes back, you know, what you injected. Mass injection. All viewers, all users, misspelled that, viewing the page execute this script. So you don't have the ability in this phase to target users, but you could target a massive amount of users. So you can redirect a whole site to somewhere else. Guest books, message boards, whatever. So if you have 1 million people looking at a message board, you post one message and you have 1 million people pointed to somewhere else, kind of like a mass slash dot effect all at one time. So we have also directed injection. How to target an individual user, say like the administrator or some account. Good ways to do this are target webmail users or HTML mail users. Webmail being like Hotmail, Yahoo, I think Rocket Mail, Lycos Mail. Everybody has a free webmail service. You know, every single stock exchange has free webmail service or a way to receive HTML messages, so you could target individual users on that system. All you have to do is get them to read your message and bang, you got them. And this is another technique here on how to hold the door open. So let's say the administrators become aware of the hole, but you're able to hold the door open for these attacks. For instance, if you're, say like there's a profile page or a feedback page that holds persistent data, well, you could hold using like layer or iLayer or something like that, where you just place that in there and you source in JavaScript. So it doesn't matter if they change the way it's inputted, because it's already there. You just hold it open. So anytime you want to do something, you just change the source of where you're getting it from, and you're through. So we'll go into some other attacks. We'll leave cross-site scripting alone for a little while. We'll go into, did I cover cross-site scripting enough yet? Okay. There's twiddling the bits. So we're going to show some OS commands examples, some meta characters, and some path directory transversal. What's important about the whole presentation thus far is what we'll go over is, as Samil explained in the Foundstone talk, is what you can do after you get to when you get to the OS command stage. What I'm going to try to cover more of is how you get to that phase, how you filter bypass, how you find those holes, what you do to get there. Because you're a lot of times you're working on systems that are proprietary. You don't know much about it. So you have to figure out what's going to work and what doesn't work and how to go about doing it. So that's what we're going to cover more of. So the power of the semicolon. Semicolon is death to a whole lot of web applications out there. A lot of times sites will ask you to put in your email address and will spam you type of thing. So a lot of times they're just piping your email address to a sendmail line and performing any kind of functions. They're just piping you directly to the sendmail line and not filtering anything. So a quick semicolon, a couple of pluses, and you can sendmail yourself the etc password file, zip zap. It'll just give it to you. And that's all there is to it. You can also pipe the commands to less. So like if you want to see what the output is, you don't want it, yourself spammed, you can pipe it to less. You could also redirect to a file, especially like if it's SUID or even if it's nobody, you can write to the directory. You just redirect it. It's very easy. And there's also the power of special characters. A lot of times, sites will list out particular files or use them as templates or whatever. Put in stars, put in special characters, try everything out. And a lot of times, you'll get the meta character to actually expand and give you all files or all listings, or use every file as a template, and error galore, and you find all kinds of good error messages. So the power of dots and slashes. So we'll start off with the example above. We have the directory, which equals path to data. It could be a whole lot of different things. This is a classic parameter path traversal. You use .. which is available on many systems, you just change the path. You just .. back up to etc password, and it'll just give up the password file to you. Now, this is not limited to the password file because most systems are shadowed, but you can get any file you want, any file you have permissions to get. You might even be able to get the source to other CGI programs that are actually SUID. So the .. So let's say the administrator gets smart and goes, okay, nobody should be trying to get etc password, nobody should be able to try and get this. So you just change the string a little bit. This is where intrusion detection evasion comes in. Firewalls don't matter. Intrusion detection is just a joke. Don't even worry about it. You just start putting .. in or .. in, go up and down, and you just start playing with the URL, and you'll get the same thing. etc /.. password is the same thing as the one above. So let's say the administrator gets really smart and goes, okay, we're not going to allow those damn .. in. You know, those are bad. We realize this now. Well, he forgot to put the little E or G on the end of his regular expression. So we'll just double them up. We'll just put double .. in. So he'll take out the first ones, and it'll end up like the one above. So we used his filters to help us out to do the attack. That was pretty nice of him. So here's some more filter bypassing techniques. So many times we'll use GET requests or POST requests, but I think in HTTP 1.1 there's about 9 of them now, so I don't have them all listed. But many times the system doesn't differentiate between GET or HEAD or PUT. It'll give you the same information. You just load that in there. It's just bad design on the part of the web server. It'll give you the same information anyway. Your web application should discriminate against the method that got used. For instance, if your CGI is only supposed to have POST requests coming into it, or only supposed to have GET requests coming into it, only allow those. Don't allow any old request to come in. Also, which URL encoding, which relates back to some of the other filter bypass stuff, is if they're trying to look for etc password or .. well, encode it, URL encode it. A lot of times they'll go, okay, this string doesn't look like etc password, doesn't have .. in it, could pass. And then it gets decoded, and it's the same thing all over again. Null characters. A lot of times CGIs will append a .html or a .txt or a PR or whatever have you to the end of your parameter. And you don't want that. You want to be able to traverse the directory and just have what you have in there. Just put a null character in there, and it'll strip off the rest. Other evasion techniques are alternate case. A lot of times they'll leave off the I in the regular expression, or they'll become case sensitive, so you just alternate the case and you'll bypass the string, the pattern filtering. Unicode's also a good way. Huge string lengths. A lot of times for performance issues, administrators will put on maximum length a string can be before it does whatever. So a huge string lengths work. Multiple slashes on directories. www.whatever.com // directory / directory. Will work just as well as everything else. It's just other evasion techniques. So more bits you can twiddle. Hidden form fields, we covered that in the shopping example, or buying the Sony Vaio on sale. We also have HTTP headers, cookies, and refers, all sorts of stuff. Anything that HTTP implements, you can twiddle, especially if the web application is using it. And we'll get into some system misconfigurations. Patches, patches, and more patches. Well, there's lots of vendor patches. If you're done your discovery well, you know what type of system it is, and you know what patches are and aren't installed, or what could not be installed. And there's also default accounts on those systems. You can also check for, the directory browsing technique, where you just start stripping off directories. You can check for software versions, again, default accounts, and you can also look, if the administrator has been posting on BugTrack or, Deja or whatever. You can also look for anonymous FTP open on the web server, just other things and stuff that are misconfigured. So to kind of round it off, some other dirty tricks we've seen out there. While being part of a web security company for a long time, dealing with a whole lot of users, I've noticed that hacks are one thing, abuses are quite another. You'll see a lot more abuse attacks in a real-world environment than you'll ever see of actual hacks or actual compromise. Users will try to destroy the system, tie up the system, bother other users, just for the sake of doing it. When there's 100 million monkeys out there, they'll start to not play nice. So what are some of these dirty tricks out there? Well, a lot of times you'll see anti-brute force code out there against web application systems that lock the account after 3 or 5 attempts or whatever. Well, especially if the logins are sequential, even if they're not sequential, just get a bunch of accounts and purposely fail them. You could lock thousands of accounts, and customer care will just go ballistic because there's 1,000 accounts that locked and nobody knows why. This goes on to a funny example that was actually theoretically used on an auction, where what the attack would be is you figure out what item you wanted to buy in an auction, some expensive item that you really wanted, and through the course of bidding over the week period, you figured out who was bidding on that item. And right before the auction closed, where everybody tries to get in their last bid, well, you use this technique and you lock all the accounts so nobody can bid on the item, and you get it. So, don't try that. Brute forcing page sequencing. This is a hybrid attack, but it works extremely well on most systems out there, especially in process flows. Works wonderful in forgot password flows, or in like banking environments where you're trying to validate the user who they say they are because they lost their password for whatever the reason. Who knows how they can forget their password is password, but it happens. So for instance, like let's say you have a system where it asks you for your name, address, telephone number. Well, or social security number matched with your name or some other piece of information. Well, if you have one, chances are you can get the other. So what you do on these process flows is it's going to try to validate you. It's going to match your zip code to your social security number. Well, put in a zip code and run through every social security number and the ID until you get it, and you move on to the next phase. Most of the time, there's no anti-brute force code on page sequencing attacks, because when you think about it, you're only supposed to look for brute force codes when somebody's trying to log in. But you can actually do data aggregation attacks against these sequence flows. So, take a bank for instance. You have the person's name. You're probably going to know their social security number. Maybe you don't. Maybe you know the zip code of where they live. And you automate the process until you get the right social security number, which is a finite key space, especially if you know their zip code, and you land in the next sequence. You might have no need to get access to their account. You just want their social security number for whatever reason. Just simple data aggregation attacks. These happen everywhere in page sequencing attacks. And I don't know, what time is it? How much time do I have? Anybody know? Oh, just about done. Okay, so the last thing, this is a new group that it's been started up a couple of weeks ago, but has some really great data on there. If you're interested in web application security, you're developing web applications, this is the group to go to. It has the most up-to-date web security-related attacks and vulnerabilities information around. There's a big group that's actually doing a lot of the work. It just had its first release of all the data. It is actually the best source for vulnerability-related information. It'll actually go further, but the project just started, but it's actually been quite successful already. If you want to get on the mobile code list, you can go to Security Focus. I believe www mobile code still works, but it might be webappsec at securityfocus.com now. But either way, this is a great site to check out. So that's that. Anyway, I'm about done. Does anybody have any questions? Is it, I'm sorry? Oh, right. Yeah, I'm sorry about that. Yeah, I'll put all updates on White Hat Sec when I get back to the States, and so you can get all the updated information there and everything like that. And there's a whole lots of other presentations there from other stuff and other information, so yeah. Questions? In the back?
Hi, you mentioned about exploits of .NET. Can you say a bit more about that?
.NET is just getting going, but .NET is mainly based off of Passport right now. And a lot of people are doing a lot better work on me, or at least disseminating it better than me out there. I don't have the links with me on those, but basically .NET is all web services based on XML, all with underlying with Passport. They're trying to do, I guess, single authentication against Passport, and you can log into any Passport-enabled site. I really don't think it's a good idea. I don't think the technology is there to be able to pull that off securely. But .NET, if it's based on XML, if it's based on XSL, there's basically been no security research on the web app layer to identify it as secure. And like I said, we're identifying problems with the XML and XSL in general, and even P3P for that matter, that's already instituted in IE6. So I would say that, .NET, take it for what it is. Any other questions? All right, cool. I'd just like to thank Black Hat for having me. Thank you, everybody, for coming. It was appreciated. Thank you.